got to drive, right? You're Mansell, correct? My name is Rob Roy. I'm the environmental director for La Jolla. Frank Spurgeon works with me. We've met years ago. Yeah, you came on out and assisted us with our ozone initial ozone study, right? Um, Actually, it wasn't ozone. You had Hunter. Nikishna Polycoptua? Yeah. Yeah. Well, I came to visit him mostly. Got it. But checked in with you. Yeah, I wasn't doing the ozone. Couldn't remember if that was you or not. But yeah, I remember visiting you guys. It's difficult when you my visit. Oh, yeah, we got time. Is it that time? It is.
Good morning. I hesitate to interrupt because it sounds like you guys are having a good time, and networking is what these conferences are all about, right? Disabled. Next slide. Well, let's go back to the first slide then. What'd you do to disable it? All right. No problem. Okay. So, good morning. I went to a great presentation last session. Thanks, Jen and Chase. Where'd Chase go? You didn't drag him along? Oh. But day 2, some people are starting to wear out a little bit. Or are you doing okay? Doing okay? All right. Well, you're here, so you must be doing okay. So my name's Mansel, and I work for the Institute for Tribal Environmental Professionals. And if you're not familiar with, we call it ITEP. If you're not familiar with ITEP, we serve all the tribes in the U.S., so 574 federally recognized tribes. I'm up to over 200 visits, but so I still have a ways to go. I'm looking for invitations. No. I've only got a few years before I retire, so I'm going to have to speed up a little bit here. But I love to get invitations to work with tribes on particularly air quality issues is where most of my funding is right now. So I look forward to hearing from some of you, and I've been making commitments throughout the conference to do some visits. So I'm already getting booked up. But today, my session is going to be about air quality education and in the context of sensors, but also air quality education broadly. So next slide, please. So, classic mission statement, but boiling it down, my objective is to work with the youth on issues that matter, community issues that matter to them, and how do we apply science, technology, engineering, and math to those issues to address them. And I actually started with this mission statement back when I was a classroom teacher. I started teaching chemistry after a military career, and I was astonished to find out that my students weren't particularly interested in chemistry. Can you imagine? I mean, chemistry is such a fascinating topic, right? I mean, the whole world revolves around chemistry, but my students weren't interested. So in my journey to figure out how to engage with my students, when we started talking about things that mattered to them, they got interested. And so my first module, as I went about this, was water. And our question was, is our water safe to drink? And I spent the next 2 months with the students chasing me around to see what water I drink. Because if Mansell drank it, it must be okay. And that's how they figured they'd answer the question. But I made it a lot harder than that. First of all, I never let them catch me drinking, other than, of course, from my water mug, and I didn't show them where I filled it up. So they had to figure out, is our water safe to drink? And I blamed it on one of our math teachers. I said, well, the math, and he literally did. The math teacher asked me, is our water safe to drink? And so I told the students, I have this question from our math teacher. So about a month later, one of my students told me how much he really disliked that math teacher for creating all this work, because they were still trying to figure out if our water was safe to drink. But we work on issues that matter to students. Next slide, please. So when it comes to pollutants, how many air quality folks do we have in the room? Come on, be proud. All right. So maybe about half. So the rest of you must just be curious about what this stuff is we're breathing, right? Because us air quality people, we know. And we know what significant impacts there can be. We also know who's the most impacted by these issues. So of course, we're talking about air quality. We're not talking just about our lungs. We're talking about our heart, our brain, the rest of our body. And of course, the most vulnerable, children. I'm really passionate about protecting our children. I now have 6 grandchildren that I'm trying to protect. And that really motivates my work. But also our seniors, and I'm getting old enough to, I'm almost to that senior stage. And I noticed the infographic I used here shows a senior with a cane, and I did have to start using a cane a couple of months ago. I had some heart surgeries, and they gave me a bunch of medication that makes me just a little bit dizzy. So if I fall over, just prop me back up, and we'll keep going, all right? Because my cane is out in the lobby. And of course, if you already have existing conditions, then air quality really matters. So for me, just being in this hotel and in the other hotel where I'm staying, I'm in an overflow hotel, is really kind of harsh on my lungs. I don't know if anybody else is experiencing issues. I see a few heads nodding. So at home where I can control things, I do much better, but I don't have as much control here. All right, next slide, please. So I already mentioned the young children, but they're more vulnerable for a lot of reasons. I had somebody ask me yesterday in my presentation, why my emphasis on children? Well, we can damage their lungs, and then it affects them for the rest of their life. So I'm convinced that I'm kind of in that category, because I have 10 brothers and sisters. Yes, 10. And I'm the oldest. And, just based on where we lived over the years, I noticed that my younger siblings didn't have near the respiratory problems that I have, but a couple of us older ones do. And I'm attributing that partially to where we lived during critical development times. But next slide, please. So this is what I'm going to talk about. I've already started, in case you didn't notice, but the list of things, but again, revolving around sensors. So I've actually been working in sensor technology since 1983. So I was in the military, and I worked with our chemical research center, and we were developing detectors to protect our soldiers on the battlefield. A few years later, we had Desert Storm. Who remembers that? Some of you don't even have a clue what I'm talking about, but some of you remember. Well, during that storm battle, I was a really popular guy because I had the only fielded chemical detector for the battlefield. So everybody wanted one, and we only had a few thousand. So I was really busy making sure we had the sensors so that we could tell what was going on with the air, because it's something we can't see, right? So I call it seeing the unseen. And for education, it becomes a real challenge, because how do you teach something about something you can't see? I've been trying to do it for over 25 years. And I can tell you, and those of you that do air quality and do air quality education, it can be really hard to engage people about air quality. But with the advent of sensors, that's really changed the landscape for helping at least my efforts for education. So that's partly what I'm going to share. So next slide, please. Seeing the unseen. Next slide. Next slide. Sorry. Okay. So you've probably seen this diagram, at least the air quality guys and gals, many times. But particulate matter, and this is stuff that is really small, and the smallest, which is also the most dangerous, you can't really see. Now, in a distance, you know, when you have smoke or dust, you might be able to see it, but especially in indoor environments, you're typically not going to see it. Although I was at a small school on the Navajo during a dust storm, and this school sat right in the middle of bare earth all around it. And during a dust storm, you could see the air in the school building. So it does happen from time to time. But these PM particles can be very hazardous to us, especially as they get smaller and get deep into our lungs. Next slide, please. And even to our bloodstream. So there's a number of sensors that are available now for measuring PM. How many of you have purple airs? All right, so about a third. Yeah, all right, celebrating here. Purple airs now are almost all over the world. And in some communities, and here in California, they're really thick. My neck of the woods, we're still pretty thin with purple airs. But this is a device for measuring particulate matter, and it can be available on the internet or not, depending on how you set it up and whether or not you want that information shared. And they have both an indoor and outdoor. So I placed one in the community just north of Flagstaff that was both indoor and outdoor. And one day I was peeking to see what was going on, and I saw their PM levels shooting up pretty high. It was in the orange zone, and this was indoors, so that was pretty strange. So I called up the teacher and asked what happened, and the chemistry lab blew up and was burning stuff, and it permeated the school. A few months later, I visited that school and walked down a hallway and found some really high PMs with one of these sensors, and it turned out they were cooking fry bread, which, who loves fry bread? Now, I was on Navajo, so it's Navajo fry bread. But anyway, they were cooking fry bread, but they had a little problem. The vents in the kitchen weren't working, and they had 20 students cooking fry bread. Now, I found it astounding just to see 20 different pans going with grease, hot grease, and high school students. And but there was no exhaust fan, and my sensor turned purple. So if you don't know, purple air is named after the highest rating on the AQI, which is purple, which means extremely hazardous air. And there was 20 students in that kitchen with extremely hazardous air, and I was there for about 30 seconds before I left. But there's other devices, and you have one of them on your table called a wind tracker. And no, these are not gifts. I want them back. I know, I see a few of you frowning. But the wind tracker, it's the little, well, it's the one in the picture. And I see some of them are on. Did Chase ever show up? Are you here, Chase? He's really good at this. I need a volunteer. So, oh, all right. I had a lot of volunteers, but you're close. So, all right. So we want you to dance. Oh, you did. You can just stomp if you want to, but don't stomp on this, but put it by you and stomp and shuffle. I'll even help out a little bit here. So this device, it needs to be connected to You're not near as good as Chase was. Keep stomping. There you go. So hold it up so everybody can see. So it connects to a phone. So a lot of these sensors rely on phones for data acquisition, either data logging and or displaying. This one has either color coding. Boy, you really got it going. Either has color coding or numbers, and so the numbers you have to get via the phone. So, but otherwise, it also has the color coding. And if you're not familiar with it, the AQI, red is actually, I think it's purple. Yeah, I think it's supposed to be purple. That's pretty bad air. And what did he do? He just stomped on the carpet. And actually, I'm going to move away from you. You kind of messed up the air here. So, a side note, you can understand why, as an air quality guy, I really dislike carpets, especially in a school where kids are moving around a lot. Adults tend to be a little more static. Although, if you want to get up and dance, go ahead. But you're going to make the air horrible. So maybe just stay sitting for a while. But my main reason for liking this one is it's simple, it's easy, and it's cheap. But it's currently out of production. I can't find anybody that's selling them at the moment, and I don't know, it might be permanently out of production. And when you get something that's cheap, they often break fairly easy, and this is true of this particular sensor. But it's inexpensive enough that I can get a bunch of them and I can put them in the hands of students, whether they be adult students or students at high school or middle school or even grade school, and they can monitor their own air quality. One of my activities is to do school assessments, and I have the kids help me out. So I spend a day teaching them about the air quality, teaching them about why it matters, and then how to use the instruments. And then the next day, they get the mission to go to a couple classrooms and take measurements and bring back the data. And throughout the day, I get all the classrooms measured a couple of times, and the students are reporting the data in, and we accumulate all that and hand it off to the principal. So that's one of my methods for doing air quality education, is having all these sensors that the students can actually make their own measurements. Now, when I bought my first PM sensor, about 20 years ago, it was $5,000. Do you think I'm going to give that to a student? No. So, I mean, the landscape has really changed now with these low-cost sensors in the education arena. So the other way is my students that come to my courses for tribal professionals, and I see a few of my fans out there, yay. Did you get to go to my courses? You didn't get one of the low-cost sensors, did you? I know you did, right, Ava? You didn't get one, but you used one during the course. Yeah, so I don't remember if you were one of the ones that reported to me your efforts and you're already monitoring. So some of the participants went to restaurants. Okay, you want to tell us about that?
Yeah. Can you guys hear me okay? I'm not used to talking into microphones. Yeah, we went to a juice bar, no ventilation. Immediately it turned red or purple, whatever it is. And when the air quality was good, we'd tell people, you have great air quality in here. If it was bad, I'm not going to tell those teenagers who are stuck in there for 40 hours a week that their air quality is terrible. So I was shocked walking in there, and a lot of restaurants we went to as well. But a lot of places, it was either very good or very bad. So I thought that was interesting.
And we know of many case studies during the pandemic where viruses were transferred in restaurants. This is a good example. Some restaurants are well ventilated and others are definitely not. And, I know that because I get sick pretty fast when I go into a restaurant that's not well ventilated and has high PM. But a lot of us just tolerate it. We think it's part of the atmosphere. But when you start carrying these sensors around, you start becoming more aware of what you're being exposed to and realize this is actually hazardous air. So it works not only with students, young students, but with adults too, to increase our awareness of what we're being exposed to, something we often cannot see. Another device, 30 minutes, I'm just getting started. Another device that does particles that I've recently been using is called a AQ-Go, and I didn't get any of these charged before I showed up. So, but I'm not trying to sell you a particular device. I'm not a salesperson. I'm an educator. I'm just telling you what I use, but I recommend you look at the market, and it's constantly changing to make your decisions. But there's a variety of reasons that I like this one, including that I like the vendor that developed it. I've talked to them many times, and they also developed some good curriculum to go with it that that they're selling. So I have a little bit of an issue with that, just because I like free stuff or low cost stuff. But I did get a bunch, and they donated me some and things. So and there's great curriculum that is supported by that. Let's see, what else do I? Oh, well, I do have some Met1 devices for PM. So I call this more the research grade. This isn't really low cost. I mean, this was like $3,500. I don't know about you, but that's not low cost to me. So, but there's other sensors that can also be very useful, but I don't let students play with this one. Just too expensive. It has a rubber boot. Maybe it'll take a couple of drops, but not as many as the high school students do. All right, so let's move on. There are a variety of education resources available through EPA resources. I'm sure at least our air quality colleagues in here are aware of Air Now. But if you're not aware of Air Now, you might want to look it up. But there's a lot of resources there for teachers and students, and many of them revolve around the use of various sensors. So like when I have my participants in workshops use the sensors, I can download a data sheet and some instructions. Chase, it's about time you showed up. So I needed somebody to stomp the carpet, and you weren't here. But great activities and lessons. And they also have some research projects. And then there's also the air sensor toolbox. So I told you I'm not trying to sell you any particular device, just more of the concept. Go to the air sensor toolbox, and they have ratings on a bunch of them and information on a bunch of them. The only problem is they're about 1.5 years behind already, because this is a fast-moving field. So there's sensors on the market that they don't have in the sensor toolbox yet, but it's a good resource to take a look at different sensors. Next slide, please. And this is just one of the activities that it has instructor guide, it has a / teacher guide, activity guide, a guide for the users, data sheets. And one of the things I like about this particular activity, which there's the link, so when you get home and they put all these presentations up on the website, you'll be able to get to the link. So it leads to action. So as an environmental educator, that to me is what education is all about, is leading to action. It's more than just information. It's proactive, and it helps students realize that they do have controls. And particularly in an indoor environment, you have a lot of control. Now, maybe the hotel would be a little upset if I ripped up their carpet, but at home, you might be able to have discussions about your furniture, your carpets, your cooking, your exhaust fans, everything. And all these things I just listed, making PM measurements is going to give you useful information. So before my boss shut me down, is he in the room? I just want to make sure I can talk smack about him. So, all right. So my boss shut me down. I was spending lots of money, especially during the pandemic when I couldn't travel. So I spent all my travel money on devices and I was giving them away. So my devices ended up in all kinds of different places, but I got a report back from one of them that said, well, I loaned it to a family that was having problems with asthma and they used it in their home and they identified a dozen different things they wanted to do differently to reduce the asthma triggers for their child. And it made a huge difference, they reported. So these low-cost sensors can be effective educationally. They can be effective helping people manage their airspace, and they can be effective in making changes, taking action to improve our situation. And so, does it sound like I'm trying to sell you these things? Yeah, I'm trying to sell you with the idea of getting some low-cost sensors and using them in your community. But, you know, I'm not telling you which one to buy. Next slide, please. So this is the action, and what can we do? All right, next slide, please. So then there's sensors, and what's my time now? 20 minutes. Do you have another sign for that? No. All right, 15. Okay. I'm just trying to pace myself a little bit. So one of the sensors on your table is called CO2 check. And again, I'm not trying to sell you this particular device, but I will tell you that I've enjoyed talking to their engineers. And in fact, they made a change and sent me a whole new production just for me, where I asked for a modification. And so these that are on the table have to connect to wireless to do data logging. Now, obviously, you see there's a screen there, and it'll tell you immediately what you're seeing. But to really be effective, you want to data log and see your carbon dioxide levels over time. So for those of you that aren't familiar with this, it's a way of measuring ventilation. I'm not measuring carbon dioxide because it's toxic, although it can be at high enough levels. But I'm measuring it because it's a measure of ventilation. So I have never seen the 40,000. I suppose you could get there, but I have seen in a few schools 5,000, which is pretty horrible. But the new production that I got was Bluetooth, because when I go to schools, wireless just often doesn't work, and the Bluetooth I can connect to my phone and do data logging that way. So they did a whole separate production for me. So I have to admit, I kind of like these guys, but there's a lot of sensors out there for measuring CO2. So shop around. Next slide, please. So as I already said, it's a screen tool for ventilation. And just a quick note here. During the pandemic, we literally learned, scientists learned how important ventilation is. We've always known it's important, but we learned that it's even more important and that we need to do it better in order to reduce transfer of viruses. So the old recommendation was a little over 1,000 parts per million carbon dioxide. And the new recommendation is 700 parts per million. So it doesn't seem like a big shift, but it's a big shift. This room is currently, is there any of them that the battery's still going? All right, so we're well below 700. We're at 618. Most conference centers do a decent job, in my experience, of ventilating. They don't want to create a COVID spreader event, so they ventilate pretty well. And at 600, I'm comfortable being in here without my mask on, as long as I stay a few feet away from all of you. If I was here as part of the audience, I'd probably still put my mask on. But at 600, you're only rebreathing 1% of everyone's air. At 1100, you're rebreathing 10%. So if we have some virus breathers, You get the idea. So that's why we've known for a long time that ventilation is important, but we know that to reduce the transfer of viruses, and not just COVID, flu, RSV, all these viruses, we ventilate and we reduce the exposure of everyone in the room. And now with sensors, we can all have our own sensor to figure out what's going on. So like Ava was explaining with PM, I do also CO2 when I go to restaurants, and there's a lot of restaurants I don't go to because they have really poor ventilation. And I don't want to be sitting next to someone who's sick while I'm eating my food, because I can't wear a mask while I'm eating. I've tried it and it doesn't work, but anyway. So again, a little bit on the numbers, but the key is here that with low cost sensors, we can keep track of our CO2 levels, and we can make decisions based on the CO2 levels. Have we passed 15 minutes yet? All right. I'm so worried about it that I had to get it passed. Okay. So with these sensors, we can monitor our air and make decisions. One of the basic decisions I make is whether I mask or not, whether I'm not even going to go back or visit that restaurant or not. In California, they actually passed a law. California leads the way on air quality. Who's our Californians in the room? I congratulate all of you for being part of it. Of course, some people curse the Californians because you're always leading the way. But anyway, they passed a law that every classroom is supposed to have a CO2 sensor in it. Now, I haven't had a chance to check too many classrooms in California yet, but when you go to schools, which I know all of you are going to visit a school in the next few months, because that's a good thing to do, right? So check and see if they have their sensors, and if not, ask the principal why not, and point out to him the law. And if you need it, I can send you the link. I don't think I put it in the slide deck. Next slide, please. So there's a wide variety of CO2 sensors. I've been using a few in my home. There's this one's another wind product. So same vendor as the little guy, and it does CO2. It also tries to do VOCs, and I use it. It's intended to be a static. So it's a low-cost sensor, but it's not a mobile one. So it's intended to be a static one and so I keep it in my work area just to keep track. And again, it allows me to make decisions about my work area, like how many windows am I going to open? What fans am I going to do? And of course, when I was at home, that was really helpful during the pandemic. And the last Region 9 conference, I passed this around and it turned purple when it got to a certain table. And somebody was getting really excited about it. So I don't think I'll pass it around. But when I came up to the table, I quickly realized why it turned purple. And I told her, shh. I was trying to get her to quit talking, but she was going, it's purple, it's purple. And then she turned to me and said, why is it purple? It's you. She was doused in perfume. So anyway, this baby turned purple with high perfume levels. So the other one that's pictured there is called an air thing. I think they ran out of original names, and so they just call it a thing. And I thought I brought one with me. Oh, there it is. So it's interesting because it'll do CO2, but it'll also do radon. So some of you, I see some heads nodding about radon. So radon is something to be concerned about. The only thing I don't like about that sensor, and by the way, I try to get as many sensors as I can and try them out to learn the pros and cons. So feel free to talk to me about it. I won't try to sell you any particular one, but I'm happy to share pros and cons. But that particular sensor, in its algorithm, if the air is dry, it shows like the red and purple, which I just don't like that because I treat humidity as a separate issue. It's an important issue, but I treat it differently than the other quality parameters.
I just wanted to ask where you like to shop around at.
Oh man, loaded question, right, Ava? All right, before I answer that question, I must admit I have a son that works for Amazon, and they pay him very well. In fact, he offered to buy me a house, but I said, "It's okay, son. Take care of yourself and your wife first." But the offer still stands, so I might end up in Seattle someday. But Amazon's a good place to start. Let's put it that way. They sell a lot of these products, or they resell them, but I look everywhere. I've even bought directly from China, and I had the salesperson call me, and we had a difficult conversation because he didn't understand English, and I didn't understand too much Chinese, but he was really excited that I bought one of his devices, and it took like 2 months to arrive because it had to come from China. But so I go everywhere, and I take recommendations from anybody, and I look and investigate. But again, I don't think my boss is in the room, so I can just say he doesn't give me a big enough budget to buy all of them, but I get as many as I can so I can test them out. So I think it's important for your own uses to try some different ones and talk to other people about it. Look at the EPA website when you're making some decisions and figure out what's important to you. Like when I'm working with youth, price is a pretty important thing because I want to get as many as I can. Next slide, please. So, oh yeah. So Oriya, let's see, I know we have a couple EPA folks. You can go ahead and wrap me out. Oriya is not all that hip on sensors, but they finally put a website up with saying, yeah, sensors exist, and they're complicated. So as far as like doing work, I've been using sensors of one variety or another for over 20 years. I know sensors are a valuable tool, so I really disagree with Oriya's approach. I've been trying to push them into acknowledging sensors, and let's put out some information, protocols, resources. So if you're not familiar with the acronym, this is the indoor air quality guys at headquarters, and they're not on board with sensors. So anytime you get a chance to talk to them, harass them, tell them Mansel said. But one of the best carbon dioxide uses, or how to use it, I guess I should say, came from the National Education Association. In 2022, they published, and it literally had everything that I can think about to say about CO2. So it's about a 4-page document, and really good. If you're going to use CO2 sensors, I highly recommend that document. And I don't think that's the link to it. So if you need the link, you can email me, but you can also just type in NEA CO2 and you'll probably pick it up. But if you can't find it, I keep it on my computer even. So next slide, please. Oh, there it is. I thought I'd put the link on there. So it's really good for helping you understand and leading back to action. So again, I'm in classrooms a lot. Some classrooms have windows that could be open, but probably haven't been open for years. But when I'm in there and measure their CO2, we open some windows. Sometimes it takes some work. I bring hammers and screwdrivers because I know a lot of windows haven't been open for a long time until Mansel comes along. But that's one of the things we do. But I can also talk to principals and HVAC technicians, et cetera, about making some changes. And there's a lot of things that can be done to improve our ventilation. But many systems are inadequate because we didn't realize how important ventilation was 20 years ago, and we didn't realize how important it was 3 years ago. So, our expectations are changing, but the HVAC technology, especially if it's in an older building with older technology, is not going to be able to do the whole job. Next slide, please. So there's a data sheet. Next slide. And action. One of my favorite actions is, of course, student awareness. I like to try to encourage the students to respectfully advocate for themselves. So when they have concerns, I tell them, well, talk to your principal, but be nice. When I was a classroom teacher, I taught my students to question authority. I know that's dangerous. And the other teachers really didn't like it because I taught my students how to advocate for themselves and how to share information intelligently, like write a letter to the editor. And a lot of people push back on that because they don't like kids telling them what to do. But next slide, please. So radon, 22,000 deaths per year. How long do I have left? Radon's really important. We're just going to add a couple of minutes. All right, no. 22,000 deaths a year. So maybe something we should do something about. Well, there are sensors now for radon, a whole suite of them. This is an old one that I've had for a number of years. And since I picked on Delbert in my last presentation, I'm going to give one to him because he's a deserving guy. But I do have a couple others, so you guys can be alert, see how you earn one. But some sensors now are actually pretty good, as in I would be willing to make decisions based on them. Some other sensors I would recommend as educational only. But back to the education piece, for me, it's about awareness, and we can't see radon. So we've got to measure it. Now, some of the tables have a charcoal test. Yeah, hold it up. So some of the tables have one, and if you're the first one to grab it, it's yours. This is not really a sensor, but it is a way to measure carbon dioxide. But it requires sending it back to a lab. But there's other devices. So I know this one has been used in Alaska for actual measurements to determine whether or not we needed mitigation. So in other words, the sensors are getting pretty good for radon. And there's a QAP for it. So if you need a QAP and you want to buy something like this, but in Alaska, it's real tough to use the charcoal sensor, the charcoal test, because the mailing time, it's just too long. When you do a radon test with charcoal, you got to get the test back to the lab within 8 days. And sometimes in some places you go in Alaska, they only have 1 or 2 planes a week. So it gets pretty dicey. But a variety of sensors available for radon. And I highly recommend using them. I'm just poking my head in to see if I packed a couple more. If I had another half hour, do I have a half hour? Oh, God, you guys are so cheap on your time. So another fun way to do it, this is a Geiger counter. So it's a form of a sensor. It senses radioactivity, specifically gamma radiation. And if you don't know what I'm talking about, don't worry about it. You can talk to me later. But you can take a balloon and rub it on your head if you don't have too much greasy stuff, and create static electricity. And then you can go around and you can sweep up all of the charged particles in the room, and then our Geiger counter will measure that. So it's an indirect measurement of radon. It's not precise enough to make decisions, but it's fun to do, but it takes a while. So I guess we don't have time to do it. Next slide, please. So again, there's a lot of educational resources about radon available through the EPA, including public service announcements, children's books. There's some written specifically for Native American audiences. So a lot of resources there. And now with these new sensors coming out for a couple $100, or look pleadingly at Mansel, you can get a radon sensor to tell you what levels are and help you make decisions. And some of those decisions can be as simple as increasing ventilation. And since you have a real-time sensor, you can actually keep track and make sure you're keeping your levels down. So we have ITEP staff, our radon expert, had a closet that was high in radon, and she used to play around with it and keep track of in her office. And she knew certain configurations of her office, like open windows and stuff, that she could keep the radon levels down. Next slide. Lots of different choices. Next slide. And action-wise, of course, if I'm working in a school, I love to report it to a principal. Oh, man. I was trying to keep my back to you so I couldn't see. And of course, you can also test homes and make important decisions for your own home. Next slide, please. So I list this link because it's a partnership with University of Montana, Tony Ward, and they have a variety of curriculum materials for all the areas that I've covered. So PM, CO2, and radon. And they have it in a research format for targeted to high school and middle school students. So if you have the opportunity to work with students on air quality, another resource for you. Next slide, please. And just this is one of their lesson plans where it takes you through guided research. So high school students typically aren't quite ready to do the research. But by the way, I'm working with my sixth grade granddaughter. She's going to do a radon project this year. Next slide, please. Last year, she did a PM project. By the way, she wants to be a scientist. I don't know why. All right. Next slide, please. So there's my contact information. Text or email is great. If you try to get me on the phone, you probably won't get me because I'm usually out doing stuff. But I try to respond to emails and or texts. Is that a question back there? Carbon monoxide monitors or sensors. Carbon monoxide sensors near the floor or ceiling, or does it not matter? Mostly doesn't matter, but in fact, more critical is near where you're sleeping because you want that alarm to wake you up. But initially, carbon monoxide will rise, but it'll quickly cool, and it'll just mix with your air. So by the time an alarm goes off, things are in pretty bad shape, and the CO has filled the room. So it's not real critical, but I would put it next to my sleeping areas, preferentially, as a preference. Yes?
I don't know if you have time to answer this adequately, and I don't mean to put you on the spot again.
Oh, no.
But as a scientist, I'm
She asks tough questions.
Where radon gas comes from.
Well, you're right. I don't have time to answer that adequately, but I will just say that it comes from the soil. So it's radioactive decay from uranium, and it comes up through the soil into your house, and it tends to accumulate in the winter when you're closed up and you have the stack effect. And if you didn't understand any of that, that's fine, because I got lots of pictures, but I don't think they'll give me more time. But we can talk about it. Anybody wants to talk more about radon? I have a table just outside this room, and I'm happy to talk about radon.
What was the primary cause of the 1955 Air Pollution Act?
No, you You mean like what prompted it? What was it?
I don't know. You tell me. That's why I'm asking you.
Come to the table. I'll look it up on Google before then. It was probably some kind of disaster that happened, but
Right,
I'm
here,
not
man.
sure which disaster.
I think we'll do one last question.
One last question.
One last question.
Okay, well, the last question is going to get another radon sensor.
Awesome. Okay.
So while you're asking your question, I'll bring you your sensor.
Awesome.
So make it real easy.
All right. So when you're utilizing the PM monitors, do you have any way to identify the indoor air quality pollutant that is that's detected on the monitor itself, or do you use the cross-examination with the CO2s and radons at the same time?
Wow, that was about 4 questions.
Sorry.
Which one do I answer? All right, so now keep her the microphone because I'm going to have to go through this. So, because we're going to give her a bonus real quick because we got another group coming in and people need to leave. So you're talking about PM.
Yes.
And cross-referencing with all those others.
Yeah, I was wondering, we utilize the PM monitors, the purple airs, and a lot of times when we provide back our comprehensive reports, there's questions about what indoor air pollutant is causing it, whether it's mold, dust, secondhand smoke.
Okay,
But those monitors aren't capable of.
that is exactly
spacing it
right.
out.
All we're doing is identifying that it is PM, and then we have to use this thing called sight and nose
Okay.
to try to figure out the source.
All right.
And in my experience, most of the time we can find the source, but sometimes it can be pretty elusive. Like one school I worked in, it turned out it was the HVAC itself
Okay.
was deteriorating and it was releasing PM into the classroom. And it took us about 3 months to figure that out. So it can
Okay.
be a real challenge sometimes.